Welcome back, guys. Today we are going to look at our third class, which is networking device. Under networking devices, we are going to look at hub, router, switch, firewall, access points, and wireless LAN controllers. So let's begin our class. First, we'll start by a hub. A hub, what is a hub? Hub is a networking device that operates at the physical layer of OSI model. Hub operates at the physical layer of OSI model. It connects devices to share data. Hub connects devices together to share data. Hub is an old technology that is not commonly used nowadays. Instead of hub, we use switches. So the disadvantage of using hub is that it consumes a lot of bandwidth due to broadcasting. Broadcasting means whenever this computer sends data through hub to this computer, hub will send the data to all the computers that are connected to it. See, it will send the data to all the other computers. That's what we call broadcasting. That's really waste bandwidth. It consumes a lot of bandwidth because the hub will need to send it here. So how the hub works: when hub receives data from one device, let's say it's device A, the data is sent to all other devices that are connected to the hub. As I've already discussed, hub will send the data here. When data reaches here, the computer will say, oh, this data is not meant for me. It will drop it. When the data reaches here, the computer will say, the data is not meant for me. It will drop it. And at B, say, oh, this is my data. And it will be received there. So the symbol of hub is this one. Just a single arrow and a rectangular box. So let's move to the next device. The next device is switch. You can be asked, what is a switch? The best way to answer this question is that a switch is a networking device operating at the data link layer of OSI model. It connects devices together to share data. A switch is a networking device operating at the data link layer of OSI model to connect devices to share data. So the switch uses MAC addresses to send and receive data. Every device that is connected to a switch has a MAC address. So the switch will use the MAC addressing technology to send and receive data. Okay? Then the switch sends data only to specific devices. Now this is a new technology that is different from the whole technology, which is hub, hence conserving bandwidth. Let's say this device A. Device A wants to communicate with device B. So it will send the data to the switch. The switch will say, oh, what's the source MAC address? It's for device A. What's the destination MAC address? It's for device B. And it will forward the data direct to device B without sending to these other devices. Okay, understand? Good. Now let's describe how a switch works. A switch has a memory called its content addressable memory table or MAC address table. This MAC address table or content addressable memory table is a table consisting of port numbers, just here, and the device's MAC addresses. So every device that is connected to a switch, the CAM table will place its port number under switch port numbers and the respective device MAC address, like this one. So whenever device is connected to port 1, switch port 1, interface F01 of a switch, its MAC address will be placed here. Understood? I hope you understand what I mean. The table stores the device MAC address corresponding to the switch port number. Okay, so the MAC address of device A is this one, and it is connected to which port number? Port 1. So the CAM table will store it like this way, and all other devices that are connected to the switch. So when data is sent from one device to another, let's say from A to B, upon reaching switch, remember switch is an intelligent device, a new technology. Switch will refer to the CAM table and say, what is the source MAC address of this computer, of this data I mean, and it will find us this one. And what's the destination MAC address of this data? It will find that it is this one. Okay, and the switch will say, oh, the destination is connected to port number 11, so I have to forward the data to the device connected to that port. Okay, I have to forward the data to any device connected to port 11, because that's where the destination MAC address is stored. So I hope you understand how a switch works. It's very important because it's a commonly asked question. So the symbol of a switch is this one. Switch is just a rectangular box with the arrows pointing left and rightward, 4 arrows like this one. Okay, alright, let's go to the next device, a router. Just like we have discussed what a switch is, a router is a networking device. All these devices are networking devices operating at the network layer of OSI model. A router connects multiple or different networks. So how to explain a router? Router is a networking device. A router is a networking device operating at the network layer of OSI model to connect multiple networks. Okay, so this is a different network by this from this one and from this one. These are class C IP addresses. By default, when you have a direct connection from this computer to this computer, having this particular network, let's say the IP address will be 0.1.1, this one will be .1. By default, they will not communicate. So for them to communicate, we have to place in a gateway, a router in between. Okay, to connect the multiple or different networks in order for communication. So the router will act as a gateway to connect these multiple networks in order to communicate. Okay, so the router performs packet directing functions in the network. It directs a packet sent from one device to another in the internet. Okay, it uses IP addresses to send and receive data, unlike a switch uses MAC addresses. A router uses IP addresses to send and receive data. Like this one, it will use an IP address of this computer this is a network portion. So the IP address will be like 192.168.1.1 going forward, like this one also .1. Okay, all right. Then a router assigns IP addresses to devices. Whenever a router is configured as a DHCP server, I mean, every device that is connected to that router and configured to have a dynamic IP address configuration will be assigned an IP address from the router. Okay, then also the router chooses best path for routing. What do you mean by that? Whenever there are so many routers, let's say this router is also connected to this router, and is connected to this router, this one is connected to this router, this one is connected to this router. Based on some concept that we'll discuss in the coming classes, a router will choose the best path. Either it's this link to this one, or this one to this one, or this one to this one, to send data from one device to another. Whenever there are redundant links. Redundant links is a situation where there are more than 2 links. Okay, 2 and above, I mean. Okay, I hope you understand. So this is the symbol of a router. Okay, good. Let's go to our next device. Layer 3 switch. Layer 3 switch. A layer 3 switch is a networking device that operates both at data link layer and network layer of OSI model. Layer 3 switch performs both the switching and routing technologies. It acts or serves both as a switch and a router. Layer 3 switch is a combination. It can work both as a switch and a router. That's why it operates at both data link layer and network layer of the OSI model. It works with the same and different networks. Same network in a LAN environment, different networks when combining those multiple networks. It's also known as multi-layered switch. So this device performs as both switch and a router. So you can refer how we explain how router and a switch works to come to explain this device. Okay, and now this is the symbol. Remember to know how to draw the symbol. Okay, all right. Next device, a firewall. Most of you know a firewall provides protection or security to a network and to our devices. Okay, so a firewall can be a hardware or a software that provides a security to the network. The firewall works with the principle of filtering the incoming and outgoing traffic in the network. Okay, it allows the good traffic to come in the network and deny the bad traffic to go from coming in the network. It denies any bad traffic in and out of the network, allows good traffic in and out of the network. Traffic is just like packets or flow of data, yeah, that has been sent from one device to another, the stream of data or packets. The firewall protects against malwares. Okay, first it provides security to the network, also protects against malwares such as viruses, you can name them. Then to some extent the firewall can stop hackers. Okay, so this is a case study, this is a scenario. This is a firewall. So this is the internet and this is our network. Let's say this one is our LAN environment. Okay, and this is an internet. So any traffic coming will have to be filtered first by the any incoming traffic will be filtered by the firewall, then allowed in the network. Any outgoing traffic will be filtered by a firewall, then to the internet. In case there is any bad traffic or any suspicious traffic, it will be dropped. Okay, alright. We have three types of firewalls. One is packet filtering firewall, also called access control list, that is configured in the routers. We'll learn about it in our coming classes. So the packet filtering firewall, whenever a packet matches, it is allowed. But if it doesn't match, the packet is dropped or blocked. Okay? Packet filtering firewall checks the source IP address and the destination IP address, plus the source ports and the destination port. Whenever these IP addresses or port numbers doesn't match the rules that are applied in the firewall, the packet will be dropped or blocked. But whenever they match the rules that are applied in the firewall, the packet is accepted. Okay, one disadvantage of this type of firewall, the packet filtering firewall, it cannot check the payload. Payload is the data inside, the content of data inside that traffic or packet. Okay, the content of data inside that traffic. Proxy firewall. A proxy firewall, also called an application firewall. An application firewall is a type of firewall that you can download and install in your computers, such as FortiGate. We have Norton, we have Avast endpoint protection, etc. You can go and look at them, download them, and apply in your computer. This type of firewall, proxy firewall, checks both the source and IP and the destination IP addresses, plus the source and destination ports. Okay, the proxy firewall checks the payload, unlike the packet filtering. Okay, the proxy firewall will check the data payload, the data inside the packet. So it's the best. It's good. It's better than this one. Okay, then the last type of firewall is hybrid. Hybrid is just a combination. You can combine packet filtering and proxy. Okay, and it's the best of all. Okay, I hope you understand how firewall works and the various type of firewalls. And the next device, access points or wireless access points. It's a networking device that creates Wi-Fi or wireless network. Okay, also known as wireless access points. Access points creates Wi-Fi or wireless network. They enable users to connect to the internet. Okay, like this point. This one is internet. This one is user 1. This one is user 2. This one is AP. This one is a router. This one is a router. This one is a switch. So, and this one is Wi-Fi. I mean, this one and this one is radio signal. So the access point will create Wi-Fi. So every device will connect through the Wi-Fi to the net, to the internet. So the device 1 will connect through this Wi-Fi, its SSID or name, network name, and you include password in order to connect to browse or to get online. Example of access point. This is how access point is drawn, the symbol. Understood? Good. Next, wireless LAN controller. Wireless LAN controller or wireless, just wireless controller. It's a networking device that controls many access points. Wireless LAN controller controls many access points. All the access points in the network are connected to the wireless LAN controller. Mostly it's being used where there are many access points or in large companies, you know. Yeah. So let's see, there are 3 access points. Okay. They are all connected to this wireless LAN controller. 1, 2, 3, 4. Okay. So these are APs, access points. They are connected to one wireless LAN controller. Wireless LAN controller connects several access points. Okay, and you know what access point does. Okay, now this is the symbol of a wireless LAN controller. I hope you understand what wireless LAN controller is, what it does, and the symbol. Okay, so in the next class, wow, that's the end of this class. So this class is very important because most questions are being asked from this class. So just a recap, we looked at hub, a router, switch, firewall, access points, and WLAN controller, wireless LAN controller. So you have to understand what these devices are. First, they are networking device operating at which layer. You have to know that. Okay, good. So kindly read about this topic, understand what I mean, and go for further researches for your examination purposes. Okay, so that's all for today. Let's meet in our next class next week on Monday. Bye. Have a nice weekend. I love you all. Bye.